All right, so for today, we will be plotting the lift coefficient in alpha, drag coefficient in alpha, and the ratio in alpha, specifically for Clark Y airfoil and a viscous turbulent flow with a Reynolds number of 1 million. So to begin, we'll get XFOIL open, and you can see I already have the Clark Y text document here with all of the data. This is from the UIUC website with all the airfoil data points that we'll need for XFoil. So using XFoil, first thing we're going to want to do is load up that text document. It was called clarky.text. Here we set pane, keypar, and that brings up the foil. After that, we're going to want to change the number of panel nodes to 250 and 250. We'll change the density ratio to 1, and then that's it for that. So you'll see it's updated here on the left. After that, we do operation. You'll see it says operation I for inviscid, and we want it to be viscous. And then it prompts us for the Reynolds number, which we said is going to be 1 million. Okay. After that, we change the iteration from 10 to 100. Pack. It's going to prompt us with a file name that we want to save this as. We'll put it as Clark Y viscous turbulent. Okay. And then the data we're going to be gathering asequential. So it's going to be from an angle of attack of -5 to 20 with an iteration of 1. Okay, so there's all the data, and it should be saved. There it is, Clark Y viscous turbulent. Okay, so next we go to Excel, and this is the data for the other airfoils, the NACA 0018 and NACA 2418, and we're going to be plotting the Clark Y against these airfoils. So we'll do open, browse, make sure it's in all files. So we go to Clark Y viscous turbulent. That's the data that we want. Yes. Next. Finish. Remove leading zeros. All right, so we're not going to do that. Okay. Right, so here is the data that we just obtained from XFoil. I'm just going to copy that, paste it here, so it's all in the same spreadsheet. And so first thing that we have to do is plot the lift coefficient in alpha. So we go to insert, scatter plot, and we'll select data. We're going to add the first one, which is going to be the NACA 0018. The x values is going to be alpha. The y values is going to be the lift coefficient. X values alpha. Y values lift coefficient. This is Clark Y. Alpha lift coefficient. Okay. And so from here, we'll add a title, the legend, so we can tell which one is which. And just clean it up a little bit. Okay. So we said this is for the alpha versus the lift coefficient. So on the y-axis here, we have the lift coefficient. On the x-axis, we have alpha. Okay. So that is for first part. We're going to do the same thing again with alpha versus the drag coefficient, and then yeah, we also need to include the ratio. Do that for all of them. Okay. So next, same as before, scatter plot, smooth lines, insert data, select data, drag coefficient this time. Okay. Okay. I will spare you from watching me put in all the rest of the titles. Okay, and then the last part is the ratio. Okay, so there you have it. That is going to be the data that we have obtained through XFOIL, plotted out against each other with all three airfoils on the same plot, one for the alpha angle versus the lift coefficient, alpha angle versus the drag coefficient, and the alpha angle and the ratio, lift to drag ratio.